the final part of the system to talk about is the visualization aspect, and this has actually undergone quite a few changes recently. So I'll take you through our sort of offerings in the visualization space. As Rose and Brian have mentioned, we offer two different types of visualization, Jupyter notebooks for more complex technical and custom visualizations, and drag and drop style visualization to kind of get a quick visualization out of some output. And you can do some quite detailed stuff with that as well. So this is the main visualizations page where you can sort of see all the visualizations you've got access to. I'm actually logged in as an admin, so I can see all of the visualizations that people have been doing recently. And from here, you can manage each visualization, changing the title and description if you wanted to. And you can also decommission these visualizations as well. So that frees up resource because obviously all of these are running things on the DAFNI system. So I'll take you through the drag and drop kind of interface that we've got to start with. And this is a really recent addition to the platform. So this visualization is made up of the output data sets from the COVID model that Rose was just showing you, as well as a couple of bonus files that I put in just for demonstration purposes. And so at the top left here, we've got a drop down, which is all of the different input data types that we can choose from. So currently the plotter tool supports CSV, TOPR.json and GeoJSON files. So if we select CSV for now, and then pick from a CSV file list. So these are all the CSV files that come out of that model that Rose was just showing you. So if I select this file, which is essentially a list of all of the different cases of COVID-19 across the UK, split up by the sort of case severity, essentially. So you've got mild, moderate, severe, and critical cases, and that's then divided into the regions of the UK as well. So what's happened as I've selected that CSV is this section down here, this column section, has pre-populated with the list of columns from my CSV file. So there's quite a few in there, but obviously if we listed all of them in this field, the page would go on forever, but we can add new fields from the CSV if we scroll through here, so we can see all of the information within our CSV file essentially. So what's happened as well is that we've got a default geometry that's come up here, and the geometry is kind of just what kind of plot we want to make. So if we click add geometry, we could add different types of geometry, and you can see there's loads of different types here, and these are all under this thing called the Vega Light spec, and so I'm not going to go through each of these in detail, but you can see there's quite a few different plot types that we could make, but we'll stick with a line plot for now just because it's easier. And so what we then do is drag columns from our CSV into the line graph. So you can see that we've got an X and a Y axis and a color that we can choose from. And these are called the aesthetics of the graph, essentially. And so T over here is the time, and more specifically, it's the number of days since January 1st, 2020, when sort of all the COVID stuff started kicking off. So we can drag T across to the X-axis and then drag the number of mild cases in the East Midlands across to the Y-axis. So you can see we quite easily get quite a nice plot of our data. So, you know, if you were coming to explore the output data set and just wanted to get some information, you could easily do it through this interface. But if we want to do something more complicated, we might want to compare what's happening in the East Midlands versus what's happening in London, for example. So we could add a new geometry type, add another line plot, and then again drag T across the X-axis and drag the London cases across to the Y. So now we've got two lines, but it's quite hard to distinguish between them, obviously, because they're both the same color. So what we can do is just change the colors of them in here. So we have blue and red. Red's obviously London, where it peaked much earlier, and then obviously a much higher peak as well because it's much more densely populated. And we can configure a load of different stuff about this graph. So we can change the title. So days since 1st of January 2020, for example. We change the axis label on the other axis, number of cases. And so you can see you could quite easily start to build up quite a nice plot of the data, and you could then share that with other people on DAFNI as well, or just use it as a data exploration tool. So one other plot type we could show would be the cases per region. Let me just refresh 1 second. This does happen sometimes. So the cases per region, this is just a file that I came up with, and this is essentially the total number of cases split by region, according to this prediction, essentially. And so if we do color by region, and then, oh no, I've got the wrong plot type, sorry. Let's add a pie chart plot. And then we'll color by region, and then choose the angle as the number of cases. So you can see that's quite a nice pie chart. Again, some of the same colors are used here. So we might want to add a new aesthetic. So we can add a tooltip, which again maps to the regions. So you can see the name of each region pop up as I hover over each segment, which is quite nice. And then the other kind of plots that we can do are sort of spatial type plots. So we support TOPA.json and GeoJSON files as well through this interface. So if I select TOPA.json, I've only got one file to pick from, and this file essentially shows the number of infections in Finland. So this is the only sort of GeoJSON COVID thing that I could find on the internet. So this shows that, yeah, the number of infections by district within Finland. So by default, it loads this sort of nice outline of Finland, but it doesn't really tell us anything. But down this column section, you can see again, it's pre-populated. And these are the features within our TOPA.json file that we can then use to sort of color the map in, and so actually get some useful information. So if we select the fill aesthetic type, and then select the result, which is just the number of infections, and drag that across, you can see the map updates, and we can see the number of infections by district, and you can see the Helsinki down the bottom obviously has the majority of the infections. Again, we could add a tooltip, and then on hover we can see the actual specific number of infections within that district, which is quite nice. So yeah, the whole idea behind this was that we could create visualizations quite easily, and hopefully it's an intuitive interface for people to be able to create quick visualizations. And I should say thank you to Martin Robinson from Oxford University, who was he led the development of this essentially for DAFNI, and that is a really cool piece of work that we've now taken and actually integrated onto the platform. So what we also offer is a Jupyter Notebook type visualization, which allows more customization for technical users. But as Brian said, it does require people to actually be able to write code. So we don't expect this to be used by everyone, but it does allow people that do have that ability to do more with their data. So this is what Jupyter Notebook looks like for those of you that aren't familiar. We support writing code in Python, Julia, and R to do any kind of post-processing on your data. So you're kind of free to do whatever you want. It doesn't have to be restricted to making visualizations, but that is chiefly what we put it on there for, essentially. And so in this data folder, we've got all of the data sets that have come out of our model once it's finished executing. And it actually makes for quite a nice data exploration tool, so we can actually explore the CSVs within the Jupyter Notebook itself and get a bit more information. But what it's primarily used for is to write some code to do some post-processing, to do some visualization. So this is one that I wrote earlier. Well, actually, no, that's a lie. I did not write this. So this is, again, came from Imperial College London. So I've sort of adapted it to be a bit more demo-y. I'm not going to go into the technical details of this at all, but this is all R code, which will essentially iterate through the results that came out of the model and draw some nice graphs. And again, the level of customization you have in here is kind of limitless. It's up to the language and the packages that you use, and you're kind of free to do whatever you want. So if I just run that code, it should run through and then produce some plots. So this is, again, similar kind of plots to what I was doing in the drag and drop interface, but a bit with a few more regions on there, showing different kind of results by age group and region, stuff like that. I'm not going to go into the results too much because I'm aware that we're running short of time. So we'll leave it there and then hand back to Jim. Thank you very much for listening.